So I left off the last video talking about specifically continuous functions and what the intermediate value theorem says. When I say continuous, I mean that from the very beginning, we're talking about a smooth curve on a polynomial. There's no breaks. It's a very nice smooth graph. So that's a continuous graph, kind of in a, for lack of a better term, that's what it means for something to be continuous. What the intermediate value theorem says is that if you have two numbers on your function that you're dealing with, a and b, doesn't matter which ones you pick. Let's say a is less than b. All right? If we know that these two things, when you plug them in, are not equal, if they're not equal, then every value between the two is reached by the function. So this is a hard concept to talk about without seeing a picture of it, and it's something that we talk about in calculus, specifically how you see it from a graphical standpoint. We know that since this is an odd function with a positive leading coefficient, it starts this way and it's got to finish up here. So at some point, we know it's negative and it finishes positive. So that means because it's continuous, that at some point it has to cross the x-axis. So we're going to find out where that is. And I'm going to plug in some values and figure out where that might be. Because we don't have a real good way to solve something like this. Because it's not a quadratic and it has no factorable parts to it. So what we need to do is plug values in. So if I plug in -2, I'm going to get -8 plus 4 plus 1. That equals -3. So I'm very close to the x-axis. So it goes down very quickly. If I plug in -1, I get -1 plus 1 plus another 1. That equals 1. So I've crossed the x-axis at some point here, between -2 and 1. Let's see what happens when I get 0. That's going to be 1. If I plug in 1, I get 3. So it's possible that it could have crossed back here if it went down very quickly. But it's more likely that it looks something like this. So what we know is that we can't get an exact value for this. But if we have a graphing calculator, we can approximate it. But we know that it has to be, the 0 has to be between the values of -2 and -1. So it has to be between those two, because at -2 we had a negative answer, at -1 we had a positive answer, and this is a polynomial, so it's got to be a smooth graph. So that's how you can use the intermediate value theorem in graphs to determine where zeros are. And if you want a graphing calculator, this can actually find an answer for you as well.